Hi guys, welcome to this video. Today we're going to build a production-ready ETL pipeline. It's going to be an AWS project. It's going to be an end-to-end project using AWS Glue for transformation. We're going to use AWS S3 for storage, Athena for SQL analytics, and everything is going to be provisioned with Terraform. It's going to be fully automated. It's going to be trigger-based and analytics ready. So to summarize the objective of this project, the ETL job is going to take some sample sales data in the form of a CSV file. It's going to read the raw data, transform and filter rows, and convert it to Parquet. It's going to break down the data for efficiency, meaning it's going to use partitions. Now, why is it important to use partitions for the data? Imagine if your data set is about 1 terabytes of data and you run a query without partitioning. Athena may scan the entire 1 terabyte of data for each query. With partitions, Athena scans only the relevant partitions. This dramatically improves the query performance and reduces costs. Now let me show you what our sample CSV data looks like. Now here's what our data looks like. As you can see, it's very simple. There's nothing too crazy about it. We have just 4 columns here: order ID, customer, amount, and date. And it's not too many lines. As you can see, it's just 101 lines. Now let's take a look at the ETL job that we're going to be running with AWS Glue. So in the top section here, we import important things like Glue context, Spark context. And as we scroll down, we see that we are basically passing in some parameters using Terraform, mainly bucket name, raw database, process database, raw table. As you're going to see below, we're going to be using these during this job. And as we scroll down, we see that we are using dynamic frame. We're also basically converting string date column to Spark data type. We're going to convert the date to a format that is preferable. We're also going to remove rows where date conversion failed. We're going to be adding specific columns. We're going to be adding a year column for partitioning and a month column as well. And in the bottom, we're basically going to be writing the process data to S3. And as you can see here, it's going to be in Parquet format. And here's where we specify the path for the S3 bucket. The partition keys are year and month. So let's go back to the slides. Now let's take a look at the architecture that we're going to implement for this project. So we start off with the raw CSV data, which is going to be uploaded to the raw folder of the S3 bucket. This is the raw folder. We have several folders, and I'm going to explain what each folder is for. So after the CSV data is uploaded to the S3 bucket, a glue crawler is going to detect the schema automatically. It's going to create a table in the Glue data catalog, and we're going to call it the raw table. Now, once the crawler finishes doing its job and it creates that raw table for us, a trigger is going to automatically start the Glue ETL job. So we have all of this inside of a Glue workflow, so this is going to be done automatically, right? The ETL job is going to basically read from the Glue catalog. It's going to clean and filter the rows, do all of those things that we just talked about when we were looking at the ETL code. And then it's going to write the processed data into the process folder of the S3 bucket. Now, this processed data is not ready to be used by Athena just yet. So another crawler is going to run, and it's going to discover the Parquet schema inside the processed folder of the S3 bucket. And what it's going to do is it's going to create an analytics ready table, which we'll call processed. So because we're using Parquet, as well as partitioning and structured metadata, the queries are going to be a lot faster, cheaper, and it's going to be production ready. So when a user comes and writes a query to Athena, Athena is going to pretty much use this process table to gather the results. And after that, it's going to throw the results into the Athena results folder. So why are we using Terraform for this project? Well, if we click around, it's going to be hard to reproduce the steps, right? Writing our infrastructure in code allows us to version control it and see the history of our changes. So this makes it repeatable, easy to tear down, and it enables us to use the infrastructure as code in the CI/CD pipeline as well. So we can automate things when we have everything written out in code. Another thing you might ask is, why are we using Docker? Well, this is more of a personal preference. I wanted to keep all of the tools and dependencies isolated from each other. So I have a lot of projects on my local machine. So each project has its own tools and dependencies. So I wanted to make sure that all of those projects have their own isolated environments that they're running in and they don't overlap. I also want to make sure that my local machine does not have any of those tools that those projects are using, right? I don't want the Python version of my local machine, for example, to conflict with the Python version of whatever apps that I am building on my machine. Another use for this is that you might have a few AWS accounts on your local machine, such as your personal AWS account and your work AWS account. So switching between them sometimes can be frustrating, and setting it up locally on your machine can also be a little bit confusing if you're not familiar with AWS. So some of you guys might not have built an AWS project before. So I thought that this would be a little bit easier for you. All you have to do is use the AWS credentials as I'm going to show you in this project. So here's our project folder. As I told you, we're using Docker. So we're creating the Docker image using Terraform, and we're installing AWS on the Docker image. There's also a script to set up AWS credentials, as well as GitHub credentials in case you might need that. We also have this private key file, which is basically where you're going to paste your private key if you are going to be using SSH for GitHub. We also have this env file, which is basically where you're going to inject all of your secrets. I've also created this README file, which is going to basically help you understand what this project is about. We have the project structure, and it's going to walk you through all of the commands that we're running, and eventually it'll walk you through how to clean up the project as well. So let's take a look at our Terraform files. So with regard to Terraform, we have our backend bootstrap folder and our infra folder. So our backend bootstrap folder consists of the S3 bucket that we're going to be using for our backend, as well as the DynamoDB table. Now inside of the infra folder is basically where we have all of our infrastructure, right? We have our script that I showed you earlier. We also have our Terraform file for the Athena workgroup. And the Athena workgroup is basically to set the result configuration, basically where the results for the queries are going to go. And it specifies the S3 bucket for that over here. Now we have the Glue Terraform file over here, which is basically has all of the Glue components that we're going to be using. We have the Glue database, we have the Glue crawlers that we're going to be using. We also have the Glue ETL job. This is basically how you set up the ETL job, and you also inject your arguments or your parameters this way. So those parameters that I showed you in the ETL job earlier, the Python script, we inject them over here using Terraform. So we have also a workflow, as I mentioned earlier. So when we are triggering different parts or components of this project, it's all going to be set up under the Glue workflow, right? And we have a couple of triggers that work with that workflow. So you need a workflow and you need a couple of triggers. And each one of these triggers has a different purpose. So this first trigger here is basically to start the workflow. It's going to basically run the first crawler. And then this second trigger here is going to run the ETL job when the first crawler is done, it's finished successfully, right? And then after that, there's going to be another Glue trigger that's going to take place after the ETL project is done. And this one is going to crawl the process data that the ETL job spat out, right? So this is basically going to crawl that data, and it's going to make a table ready for Athena to use for our queries. We also have a lot of IAM credentials that we need to take care of. And I've separated the IAM credentials based on what service they belong to. So we have some for Athena, and we also have some IAM for Glue, as you can see, right? So there's a lot of permissions that you need, and I've set it up here for you. No need to go look it up yourself. This should work fine. And we're going to run the project in a moment, and I'm going to show you how to do all of that. So this is the main Terraform file. Basically, we just specify our backend and our provider, which is AWS. Here we have the outputs. Basically, we spit out all of the outputs for our different resources here, like the bucket name, the Athena results location. All of the Glue outputs are here as well, and all of the Athena outputs are here as well. So we have the S3 Terraform file as well. And basically, S3 is important. As I showed you earlier in the architecture diagram, Glue is going to be pretty much interacting with different folders or different directories inside the Glue, inside the S3 bucket from time to time, right, for different reasons, as I showed you earlier. So we have all of the, basically all of the objects and the different folders inside of our Glue here. So we have the S3 bucket here, and we also have the bucket ownership and access controls, right? Basically, we want to specify who owns the objects that are being uploaded to the bucket. There's this weird behavior where certain resources, such as Athena, for example, might not have privilege or the permission to query certain objects that were created because it wasn't created by Athena, and it wasn't created by you. It was created by AWS Glue, for example. So to get around all of that, we have this setup. And then we have our prefixes, or basically our different paths that I showed you earlier, raw, processed, scripts, Athena results. And if you go back in the timeline of this video, you should be able to see all of these folders in the architecture diagram that we discussed earlier. And then we have some sample data, right? This is where we upload our sample data. This is the path to that sample data, and it's in CSV format. And also we need to upload our Glue script. And this is basically how we do it. Now the terraform.tf-vars file is going to be used to pretty much store your bucket name, your project name, and the region that you're setting up this project in, right? Now this file usually doesn't get uploaded onto your GitHub repo. It doesn't get pushed onto GitHub. It's usually a file for your secrets, right? We have our variables.tf file, which stores all of these variables here, as you can see, region, project name, etc. And lastly, we have the make file. The make file is basically the file that we use for our Docker commands. We don't want to keep writing a bunch of Docker commands and running them, so we use small makefile scripts. So we're going to say make build, and it's going to run this command right here. And if we say make shell, it's going to run all of this, right? And I'm going to show you that in a bit. So let's jump into the terminal and start running our project. Let's go into our project folder, ETL Glue, and then say make build. Okay, it looks like Docker was turned off, so let's go and do that again, make build. All right, it's building our project. Okay, next thing we're going to run is make shell. All right, now we are inside of the shell of the container. Let's use our readme here and run the init command to start our Terraform backend, to initialize our Terraform project. Okay, that took a while. So let's run the plan command. This command is going to compare the existing AWS resources to what you have configured in your local Terraform files. All right, so it's going to add three things: the S3 bucket and a couple of other things like the DynamoDB table, as you can see here. Okay, and then we're going to apply these changes. All right, looks like they were created. Let's go take a look. All right, and we have our ETL Glue bucket. This is basically our S3 backend, and it was successful. So now we're going to initialize, plan, and apply all of the resources in the infra folder. Let's run Terraform plan. All right, now let's run Terraform apply and auto approve, meaning that it's not going to stop. It's going to apply everything without asking us. So now it created all of those resources. Let's go take a look on the AWS console. So let's take a look at the workflow to see if it started. Okay, looks like it has. Let's click on it. All right, so here's our workflow. Let's look at the data catalog to see if the tables have been created. All right, so the raw table has been created, which means the crawler ran successfully, which means the ETL job should be running. Let's go take a look. Okay, here's the ETL job. Runs. Okay. So the job is currently running. Let's take a look at the logs. Okay. So in a while, this job should finish and basically trigger the next step in the workflow. Okay, so the job ran successfully, which means that the Parquet data should now be in the processed folder of the S3 bucket. So let's go take a look. So here we are inside of the S3 bucket. Let's go in the processed folder. Okay, the year, remember we partitioned earlier by year and months. So, okay, we have our data in here. So now a glue crawler, a second glue crawler, is supposed to come here and crawl all of this data, right? All of this process data, and create another table in Glue for Athena to use. So let's see if that crawler has created the table. Let's go to crawlers. Okay, so the process crawler is here. As we can see that the process crawler has completed the job, which means that the processed glue table should be ready. So let's go and look for it. Okay, so the process DB has been created by the crawler. That's great. And the data is Parquet. So let's go to Athena. Let's go to query settings. Let's say manage. So now we need to put in the query result location. So let's go to our S3 bucket, and the query results are supposed to be in this folder. So let's copy the S3 URI over here and paste it. Save. Let's go to the editor. So let's run this query. We're going to select everything, every column from our raw DB sales table. This was basically the table that Athena is supposed to use, that was created by the second crawler. So let's run it. And as you can see, here's our data. We have all of the columns and it was run successfully. Okay, and there you have it. Be sure to follow the instructions in the README for deleting these resources. If you like this video, please give it a thumbs up and subscribe. I'll see you next time.